This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video, we will be looking at how to use sequences to evaluate loans under the Financial Maths section. So case 2 of using sequences, where case 1 was dealing with loans, or dealing with savings, case 2 is dealing with loans. So loan repayments can be calculated in a similar way to pensions, which we will see in a future video. So let's suppose we have a loan of total value €R for T years at interest rate I, and we will be making equal monthly repayments of, let's say, €A. A is not just P over T, P being the present value, because we also have to pay interest on the loan. So each payment has some interest included in it. So each time we pay, we're not just paying to the sum of the loan, we're paying to a little bit more than that so that the banks can get their share. So if we take each repayment of €A and take off the interest, then they would have to sum to R. So if we don't include the interest, we know that all of our payments will sum to R. A payment made of A, made after n years, with the interest removed, has value A all over 1 plus I to the power of n. So if we remove all of the interest and sum, we then have that R, which is the total value of the loan, is equal to A all over 1 plus I, so we've removed the interest, plus A all over 1 plus I squared, again, removed the interest, and so on, plus A all over 1 plus I to the power of T, and T being the amount of time that has passed, whether that be years, months, and so on. So we notice that this has the same form as the sum S sub T. So we can use the geometric series formula in the exact same way that we saw from the savings video. So here, this looks like a bit of a mouthful, but all we have is R is equal to A all over 1 plus I, where this is our P term, or A term, sorry, this is the first term from this sum of numbers. So the first term, or small a, if we remember from our sequences and series videos, the first term here is A all over 1 plus I. This larger fraction we have on the top line 1 minus, and then we have this 1 all over 1 plus I, all to the power of T. So this is our common ratio R raised to the power of n, which in our case n is equal to T. And this is all over 1 minus 1 all over 1 plus I, where again this is our common ratio. We can rearrange this to get A multiplied by 1 plus I to the power of T minus 1 all over I times 1 plus I to the power of T. So to originally get this, all we've done is identify small a, R, and n with the geometric series formula, and all we've done is thrown them in. So in this case we know the total, R, we know the value of the loan, but we want to find A. So we just rearrange for A. All we do is divide both sides by A, and then divide both sides by R, and we can swap this fraction around. So what's actually happened here is A and R have swapped places, and this fraction has been flipped upside down. So A is equal to R multiplied by I times 1 plus I to the power of T all over 1 plus I to the power of T minus 1. So this is the amortization formula, and is in the tables book. However, this derivation that we've just gone through is examinable.